Hello, my name is Nikolai, and today I want to show you how to build SmartPendant from a kit. So this kit includes new redesigned PCB, black peel, some LEDs, couple buttons, 4 screws, hand wheel, and a display. So basically everything you need for build SmartPendant except 3D printed case, which you have to print yourself, and some wiring that you also have to source somewhere else. But first let's talk about difference between those two PCB. Actually there's not much difference between them except layout, and this IC is gone now. Idea used to be to connect either a UART or HM11 module, but I decided to get rid of it, and this IC just unnecessary anymore. There also, as you can see, those all through hole components, and this one is all SMD. And it's so because, as you can see here, protruding, and since display glued on VHB tape, and this tape has 0.7 millimeters, all those pins have to be milled to lower height or something like that. It's really tedious and not easy to do. Get rid of it. It just simplifies assembly very simplifies it. So also here those two combined into one, and this one moved downwards with empty space, which allow easily to connect wires, and also it allowed to use some additional modules here. For example, if your controller have RS282 and you need like high voltage, not 3.3 voltage levels on TX and RX pins, you could just place some small off-the-shelf converter here and connect it in as a middleman between wire and SmartPendant. And basically that's it. To assemble SmartPendant we have to solder 4 LED here. If you don't need those LED, you can skip this step. First LED shows request. It's actually shows on a display too. This one LED is power, which basically backlight for display. If it's light up, then device have power. And those two for RX and TX line, just blinking in case in communications. And those completely unnecessary. Also the two buttons, left and right. I highly recommend to solder those, even the same buttons on a display, but it's better to have like hard buttons, because you know one button is stop and sometimes it's really needed to stop. And to solder black peels on those connectors. Connectors is too high, so I recommend to mark those and use cutters to cut any excessive like protruding pins. 4 LED: blue, red, yellow, green. Not looking green here anyway. There are also some arrows that shows how those LEDs supposed to be soldered, but it's not really clear. So those two looks in this direction away of cutout, and those two looks in a cutout. So basically, as you can see here, some green dots on this LED on that side, on other side, and again on this side. And that's how those LEDs supposed to be soldered here. The next we have to solder those two buttons. It's much simpler, there no any directions you have to follow, just place it here and solder, nothing difficult. And the last step, we have to solder black peel to the PCB. Now we have to clean up all this mess that we made using flux. What I prefer to do, use toothbrush, isopropyl alcohol to clean this mess, then rinse in water. It's this deionized water from our reverse osmosis drinking system, and then to blow up all this water using shop vac. If there's some residues still left, then we can just repeat this procedure. Now, when this board is clean, the next step to glue display on it. And for doing so, we need a case, because I guarantee you will not glue display right in place, and it will not align with this opening. And easiest way to align all properly, just print a case and drop display in and then glue it. As you may see, all openings are closed because I just prefer to do it that way. It's just how it's printed, all in one direction, and also when you so basically it just looks nicer, but it required to open all those openings. And to do so, we can use X-Acto knife, we can use utility knife or segmented knife, or even deburr tool. The next step, trying to install it here without a display, and in my case it doesn't fit. Those things have to be trimmed a little bit, and after a little bit of trimming, now the board fits nicely. The next step is to fit display into a case. Those ribbon cables should be on top, and it probably will not fit from first try. There are some edges, so those have to be trimmed slightly. Oh, by the way, this one also can be removed. What I like to do, just use a knife and make some cuts like so, and then to cut a little bit angles until this display will fit. And after some trials and errors, it all fits quite nicely. And now display is glued to the board, and we can just remove everything together. And we have board with glued on display that will then fit in this printed case or any other different printed case with about same openings. Yeah, so some trimming still will be required, but it will be much easier to do than randomly glued display. The next step to fix encoder in a case. Nice hand wheel, 60 millimeters. We need to remove those nuts. Don't lose them. Those nuts will hold encoder here. So you may see there no hole. We have to drill it, and you may see it's not really good because 3D printers doesn't like to print in air. And to clean up all this mess, I prefer to use my milling machine. And now when we clean up all this stuff, we could try to assemble it and see how it all will fit. So these holes and other holes all aligned and all fit nicely. But before we could assemble both halves, we also need to place buttons here. And first what we have to do, check that all buttons fits and doesn't bind anywhere. For example, here this button fits and works okay, but this button is not, so it just binds here. It's because there's some artifacts of printing, which again X out a knife and clean all this up. For the back plate, those two buttons, holes for buttons drilled with 1/8 of an inch, and basically those two small buttons just drop in. They are placed for another button that are not necessary to drill because it's a key button which basically acts as this button. So those two in parallel, no sense to have another one on the back. Assemble it all kind of tricky because buttons want to fall off. Those buttons is easier to place using some tape. I used Kapton. Any tape, sticky tape should work, I guess. And for top button, I also made some cut off here on one side, which goes to the bottom. And if we look on our PCB, we can see there's some cutout for button, and this cutout should allow those buttons to just slide in. And let's see if it will place this button again here. So next we place it like that. And yep, top button is clicking, side button is clicking, and everything works together. Those are clicking, and we can install it, screw it in, and then we need some wires. To connect encoder we need 4 wires, A, B, ground, and I use 3.3 volts. 5 volts should work also just fine because those pins for encoder is 5 volt tolerant on STM32. But just in case if encoder works with 3.3, which this one does, then it's better to use 3.3 volts. A and B, I recommend to connect to A and B inverted, because those A and B has some weird looking front on oscilloscope, so A and B just clean pure square wave, and this one has some like ladder look anyway, so those two are better. After this encoder is connected to this header, then remaining part is a cable relief and a cable. And this one is also kind of tricky. I 3D printed it with closed those perimeter with one like line, and then it have to be pulled to clean this gap, and after that it should be able to slide like so, and then you take your cable and pass it through this hole and somehow pull it. Not really easy task to do. And after the cable passed through this cable relief, it can be installed here, and then we could connect it accordingly. And after everything is assembled and connected, we could take our back cover, and with installed buttons we could just connect those two pieces. So here is a nut from encoder, stud, and we have to drop a nut here and screw it in. And after all those steps, you will have fully assembled SmartPendant that can work all buttons as pressing, SD card slot, USB, and couple buttons for programming. And I also prefer to use those GX12 connectors on mine. All have same pinout. Pin 1 is ground, pin 2 is transmit, 3 RX, 4 enable, which I don't use on my systems, and 5 is plus 5 volts. And this will allow to test this unit for me. But before we go to plug it in, we also have to program latest firmware on it. So to program it, first take a USB cable and connect it to PC. What we should see here is backlight on a LCD should light up, green power LED should light up, and this LED should blink, but it's not blinking so fast by naked eye. It just slowly changes intensity. It's a default code from the Act Studio who supplies those black pills, which means that it's working. And to switch it to bootload mode, we have to hold boot button, it's a left one, and then hit reset button. It makes some sound, and now it's not blinking anymore, and it's connected in bootload mode. To upload firmware, first we're going to GitHub repository with a SmartPendant project, open release folder, and then we need to download smartpendant.hex. After we done that, we should go to STM32 Cube Programmer, and here we see that no ST-Link, and because we connected to USB, we have to change to USB. No DFU, because I launched it before enter in DFU state on SmartPendant. So I click update, and now it shows USB and some serial number. Now we can click connect, and we see there's some code. This code, it's previous one from the Act Studio, as I mentioned before. Then we go to here and erase full chip. On Windows 11 there has to be some problems with trying to programming without full chip erase, so I highly recommend do like full chip erase. Now we can see that chip is erased, and we can click open file and open SmartPendant hack that we downloaded earlier. Then we hit download, and download in progress, and it's done. Now we could click disconnect, and then we could either hit reset button or just power cycle the device. And now we can clearly see that it's running SmartPendant version 10.0, and touchscreen works, which is nice. We can go to power feed and try to change something. So encoder also works. We can check buttons. We can see that all works. And that's basically how you program SmartPendant. And the last test, I connected it to my milling machine instead my own SmartPendant, and click this button. We can see that something is changed. So everything is works. Yellow LED shows receive packets from controller, and red LED don't even blinks. It's because request too small command, but for some more longer commands we can clearly see that SmartPendant sending data. Very cool. That's it for today. If you have any questions or comments, leave them down below. Also, you can find links in description to this video, and happy holidays! See you next time. Bye.